Hello friends, welcome. Friends, this is module 5 of my satellite communication course. Other modules are listed here in my playlist. You can go and have a look at these playlists and I'm going to post the 5th module here. Now friends, what is the purpose of this module? The purpose of this module is to discuss about satellite spectrum sharing and interference management, which is very crucial to discuss because satellite spectrum is a shared resource. Unlike in case of terrestrial, it is an exclusive assignment resource where operator gets full flexibility to operate within the block which has been assigned to him. He doesn't have to worry about interference. Whereas satellite operators have to coordinate with other operators, and there have to be some rules which are defined by the regulator to ensure that the services can operate with reasonable level of clarity and fidelity. Now friends, we are going to discuss the following topics in this module: the terrestrial exclusive spectrum versus satellite shared spectrum and the risk of shared spectrum, why satellite spectrum must be shared globally, which we have already covered in the earlier module. We're going to just touch upon it. Then we are going to talk about protecting the geosynchronous Earth orbit satellites, which are at 36,000 kilometers above the surface of the Earth because of this problem of aggregated interference. We are going to talk about what is this aggregated interference. Then we are going to talk about a term called equivalent power flux density. What does it mean? Right? You don't have to worry. Everything will become extremely clear as you go through the presentation. Then we are going to talk about protecting the GEO Earth station, which are located at the surface of the Earth to receive power from the geostationary satellites. And we are going to talk about coordination versus exclusion zone. Then we are going to talk about the two non-geostationary satellites, which can be LEO or MEO, working together in a collaborative fashion and how they manage interference between them. Then operator coordination and beam management. What are these and how these are contributing towards managing interference? Spectrum splitting as a regulatory last resort means if two operators fail to resolve their differences or interference, how regulators can step in to create some kind of environment where they are forced to manage within themselves. So that is called spectrum splitting as a regulatory last resort, and why NGSO coexistence is still an evolving area, because this is not an area which has been stabilized yet. Okay, so let's go straight to my first animation. In my first animation, if I replay this, you will see that we have a terrestrial network for exclusive spectrum assignment. Here are the buildings, and then we can have multiple operators operating in different spectrum bands, right? Now, these are exclusive assignment, means nobody interferes within this spectrum band. Whereas in case of satellite operators, you will see that there are multiple satellite operators. They are sharing the same block of spectrum. It is a shared spectrum, right? So this is very clear. Everybody understands that. Now let's look at the other animation. In the other animation, I am going to discuss a peculiar problem. The satellite operators operating at different height. Because friends, you know that we all started with geosynchronous satellite Earth orbit, which is called GEO, right? Which operate at the height of 36,000 kilometers, which is huge, right? And these satellites were pretty popular in the initial days because these satellites used to cover a large area of Earth's geography. Given the height, the footprint of this satellite was pretty large compared to the current generation satellites, which are called LEO, right? The LEO are at a height of around 500 to 1200 kilometers. Because they are at a lower height, their footprint is also small, means the footprint on the surface of the Earth is small, right? Whereas in case of GEO, the footprint is pretty large. Now you will see these are ground terminals, right? And these ground terminals are trying to communicate to these LEO satellites. Means these are all uplink, and the links which are like this are called downlink. Now, because of this large footprint of the geosynchronous satellites, you will find that all these terminals that he is trying to communicate to these LEO satellites fall within the footprint of the GEO satellite. And therefore, if there are any power which leaks out, it can go and touch the geosynchronous satellite. And that is where the problem is. You can clearly see from this animation, and that might degrade the signal to the GEO, right? And it's very clear from this animation, right? Now, if you go to my next animation, this is going to become further clear. So let me replay this. Here you will find that there is a geosynchronous satellite at the orbit of roughly around 36,000 kilometers. And then we have got a geo earth station. Now, what is this geo earth station doing? It is trying to communicate to the geosynchronous satellite, right? Both uplink and downlink. Now, this particular satellite is sharing its spectrum with other LEO and NGSO satellites which are operating at the orbit of 500 to 1200 kilometers, right? Now, what is happening, friends, that all these small terminals that you are seeing on the ground, they are communicating with the LEO satellites in the uplink direction, and there are some spillovers which are taking place and hitting the geosynchronous satellites. Now, as the number of terminals here you see on the ground increases, the interference at the geostationary satellites increases, because geostationary satellites have to be configured to receive signals from geo earth station, which is at a distance of 36,000 kilometers, and therefore this satellite's receiver has to be tuned to receive very weak signals. Now, if there is an aggregated interference emanating from this earth station, these terminals which are trying to communicate to the LEO satellites or the NGSO satellites at an orbit of 500 to 1200 kilometers, their aggregated interference can create a problem at the geostationary satellites, which I'm going to show you. Currently, there are roughly around 31 NGO satellite terminals, right? This is just a reference number. It can be low, high, or whatever. If I increase the number of terminals, let's say, if I increase it, you will see that at certain point, this is going to create a huge interference. You see, 60 NGO terminals. If I reduce the terminals here, you see, the interference goes down. So at an aggregated level, this is creating interference at the geostationary satellite, and therefore what happens is this is called equivalent power flux density. So ITU specify a power flux density regulation. It is being laid out by the International Telecommunication Union that these ground level interference emanating out of the system cannot exceed a certain power density so as to protect these satellites. Okay, so this is the concept about protecting the geostationary satellites. Now, friends, there is another problem here. The geostationary satellite, let me just replay this again so that we start from the beginning. Now, the geostationary satellites are also communicating to the geo earth station. So again, the distance is 36,000 kilometers and the earth stations are located at a certain location on the country, right? There are not multiple such locations, but there are some few locations. Now, what happens is that because these LEO satellites, terminals, are also working close to the geostationary satellite terminal, which is the receiver on the surface of the earth, there is a possible of signals spilling over from this terminal and hitting this terminal, and in the process those ground signals which are coming from the satellite and hitting this terminal, those getting contaminated. Therefore, what happens, friends, in order to prevent this, what they do is they create an exclusion zone. And this exclusion zone is of such a size that all these terminals, which you see here, which are trying to communicate to the LEO satellites, they are located outside this exclusion zone. They are not allowed to operate within this exclusion zone. So this is another concept by which the geo earth stations are protected, right? Now let's go to the last animation. Let me replay this. So in this animation, what you see that there is a orbital system of multiple satellites, right, running around the surface of the earth. So we have got operator A and we have got operator B. Now what will happen at some certain point of time, you will see that the operator A satellites will have a footprint which will be just on top of operator B, and it is going to cause interference. Like for example here, you see, it's causing interference because you can't prevent an operator A and operator B, which are operating at different altitude, not to interfere with each other. So when that interference happens, there has to be a certain rule of coordination. Now, normally what happens that these two operators can coordinate among themselves by beam management, etc., right? But if they fail to coordinate, then what happens? The overall spectrum block of say certain size, which is shown here, as soon as the interference increases beyond a certain threshold level, will be split into two halves between operator A and operator B within that duration where the interference persists, right? As soon as the interference goes, then both the operators will be able to use the full block of spectrum. Like you see, let me replay this again. You see, both the operators are using the full block of spectrum. As soon as there is an interference, the spectrum is split into two different halves. You see, it's split into two different halves. Operator A 50%, operator B 50%. So that's all, friend, in this video. Hope you understood it. It's very clear that whenever a satellite operator is working in a block of spectrum, you have to assume that block of spectrum is shared, and there has to be interference mitigation techniques either within the two operators or three operators coordinating among themselves or imposed by a regulator in order to prevent the services getting impacted and to ensure that every operator has a fair deal and they are able to operate in the same block of spectrum, which is a shared spectrum, right? That's all in this video, friends. I hope that you understood what the concept is, and I'll come back with the next module very soon. As soon as I record the next module, I'll post it in my playlist, which I shown you in my channel. Thank you, friends, for watching till the end.